Good afternoon, everyone, and welcome back to another one of our Innovation Teams live innovation webinars. And I'm Mrs. Hughes. I'm with the Energy Station. I'm so glad you guys could come and visit with us. Today, you're here to join me for Snowy Science with Chemical Energy. I want to give a shout out to all of our amazing partners who continue to support us in our virtual environment. So, of course, the Chula Vista Elementary School District, the Chula Vista Public Library, the City of Chula Vista, SCG&E, NECA, and IVW, who are all part of our Energy Station partnership. Behind the scenes, I have some helpers with me this afternoon. Mr. Bruder, Mr. Garcia, and Ms. Quiros are all ready and welcome to take your questions and moderate your questions in the chat as well as your comments. So we do hope you will take advantage of that, and we want to hear from you this afternoon. Also, we're going to be having a Kahoot game at the very end, just like we have in the past, so be ready for that. Pay close attention to what you're going to be learning today. All right, so let's go ahead and get started. I don't know about you, but I love the winter season. It's a time where the air is a little bit chillier and it's an excuse to get hot chocolate. But to be honest, I really want to see some snow. But you know, living here in San Diego, Chula Vista, we don't really have the most ideal conditions for snow. I mean, we obviously live by the ocean. I don't know if you knew this, but we have over 260 days of sunshine throughout the whole year. So not really a good place to have snow. But instead, I thought, well, what can I do to maybe simulate that? How can I come up with maybe something like fake snow? So this seems like we're going to need some science and engineering. But really, what's the difference between the science and the engineering? Well, let's take a look here. Scientists, they're going to ask questions, they're going to do experiments, and they're going to make observations. And when they do those three, they draw some conclusions when they're doing their science. They also tend to do their experiments on a small scale, okay? However, an engineer, they're going to collect the information from a scientist, and they're going to think, okay, if this works out, how can we replicate this on a much larger scale? Like say we make fake snow, an engineer might find a way to make fake snow for the entire city of Chula Vista. Wouldn't that be great? So that's our big difference. And again, they do this on a much larger scale as well to achieve their goals. So you might be wondering, well, what kind of scientists do I need to create fake snow? Well, these scientists are called chemists, okay? So a chemist is someone who works with chemicals because they're going to figure out what kind of chemicals are going to artificially replicate and look and feel like real snow. So to explain a little bit more about chemists and chemistry, let's go ahead and watch this short video explaining what chemistry is all about.
Squeaks and I were just doing an experiment. We're mixing things up and seeing what happens. We're doing chemistry. Squeaks and I were just doing our experiment for fun, but some scientists get to do it all the time. Everything in the world is made of chemicals, which are the different materials that go together to make up all of the stuff around you. Everything that you can see, touch, smell, or even taste. The dirt, the air, you and me and Squeaks too, it's all chemicals. Scientists called chemists study chemicals, what they do, and how they can change. Basically, chemists try to explain why things act the way they do. There's a whole lot of stuff in the world to explain, like why does water turn to ice when it's cold? How does soap clean our hands? And why did this white stuff get all bubbly when I poured this all over it? Sometimes when certain chemicals come together, you can see a really cool reaction, the kind of stuff that chemists love to watch. Do you want...
Okay, so what I heard from her is that everything is made of chemicals, everything. That also means that everything is made of something called matter. Well, matter looks like this. It comes in three forms. It comes in a solid, a liquid, and a gas. Solids would be, well, solid things that are hard. So for example, your pencil or even the device you're watching on right now. Those are solids. Liquids, of course, are going to be like water or juice. And gases are going to be things that we might not be able to see as well. So the air we breathe, or even the helium that comes in a balloon that floats. Those are all different examples of matter in different forms. So we want to first find out and act like a scientist, what might be some ways we can combine and study how these different forms of matter behave with each other. So I'm going to go ahead and show you a demonstration using my doc cam here. And while I'm showing you my demonstration in my doc cam, while you might have some materials you're using, don't go and get your materials yet. Okay, this is just for a demonstration purpose. So save your materials, don't get them yet. This is just to watch, but you can save those materials later. So as we just talked about, matter comes in 3 different forms. Think about the forms you see right here. What are they? Are these solids, liquids, or gases? Well, the first group I have in group number 1 is a glass with some water and some ice cubes. Group number 2, I have a glass of water and a little container of salt. So what do you think these are? Solids, liquids, or gases? Okay, so if you said solids and liquids, you're absolutely right. The ones that are visible to us are definitely solids, like the ice cubes, the spoon, the salt, even the glasses themselves. And the liquids, of course, would be the water. Now, I want you to make some predictions. You can think about these in your head, but more importantly, I'd like to see if you guys can write them in the chat. So go ahead and get your fingers ready to type. I want you to make some predictions and type them in the chat for me. First prediction, number 1. What do you think will happen when I put the ice cubes in the first glass? Go ahead and type a prediction. And then prediction number 2, what do you think will happen if I pour this salt in the glass? Do you think either one of them are going to change their forms of matter? So while you're doing that, go ahead and type. I'm going to go ahead and drop in an ice cube in the glass. And I'm going to pour some salt in glass number 2. Okay, again, go ahead and type your guesses into the chat. We're going to stop and pause here and wait a moment to see if there's any change. We're going to come back to it in just a little bit, but let's let that sit there for a while. And we're going to go back and see a little bit about what we're talking about. So, as we mentioned, while we're waiting for those predictions and those guesses to happen, what are chemists and why are they so important in the first place? Well, a chemist might work on different types of projects. One thing they might do is they might work towards making better medicines. Okay, so they're using chemicals, they're trying to find a better way to make medicines or even cleaners for your home, something to be safe with. Chemists might also work with farmers, so they're here to maybe improve the soil, improve the food. Again, things that are going to help us in our environment. And because I work at the energy station, we are talking about environmental science and clean energy. One big part that chemists are involved in is finding better, safer, more efficient forms of energy for our everyday lives, like fuels for cars. Did you know that actually the cars your families drive, if they're gas powered, are actually partly made from corn fuel? And that's what a chemist has figured out, is that corn fuel can actually produce cleaner energy for not only the car, but for our environment and our air. These are called biofuels. There's other cars like you see in this picture here that are completely operating on something called hydrogen. That's a chemical that can be used, and it doesn't produce any pollution. It only produces water as its byproduct. Okay, so Mr. Bruder, this is a good time. We can pause and maybe collect and see how many predictions that maybe we have in the chat, or even just some questions or comments.
Hey, Mrs. Hughes. Yeah, we have some great comments and predictions coming in. We have one from Francisco saying that he thinks that the ice will float back up.
Okay.
Also, a couple others. Sophia saying that she thinks the the ice will float and the salt will sink in. We also have Josiah, who thinks that the salt's actually going to disintegrate. And Zoe, who thinks that the ice is going to melt in that one.
Oh, wow. I have a feeling that our viewers have seen ice and water several times and kind of know what's going to happen. So let's go ahead and look back at our experiment and see what the results might be. Okay, so I'm going to come over here to my ice, and I do still see the ice in there. I'm going to take it out. It looks significantly smaller. Let's just compare it to another ice cube. And you can tell there, oh, it's definitely shrunk. So some of those predictions, I think you guys were right on the money. And as far as the salt goes, I see some of it, you can't tell, but it's at the bottom of the glass, but when I stir it, it gets kind of cloudy, but it's just not really easy for me to scoop out, at least not the way it was when I first put it in the glass. So how did those predictions come along? It sounds like you guys actually got the predictions just right. So there is an explanation for what we just saw and why we saw it. The first glass that we just looked at, the ice and the water, that's called a mixture. Okay, a mixture means that you're combining two or more forms of matter that can be separated. So if I wanted to, I could take out that ice for a little bit until it completely melted, but I could separate the two of them. I can take that solid out of the liquid. Here's some examples of other mixtures that you might have in your kitchen. The other one, glass number 2, was a solution, meaning we combine two or more forms of matter, but they're so spread out, maybe evenly spread out, they seem to disappear. You could separate the salt out of that water, but it's going to take a lot more time, maybe just through certain processes like evaporation or using some heat. So here's some examples of solutions. You see any similarities there? Both were liquids as well. We call that, when they seem to be disappearing, dissolving. So when something dissolves, it appears to have disappeared into the rest of that solvent. Can you guys think of any other mixtures or solutions? You can type that in the chat as well. So we're going to go to our engineering design process that we've been using several times. And I want to identify my problem, which is there's no snow here in San Diego. And I want to come up with a solution of creating a safe recipe of fake snow that I can maybe use to play. But if I look at my process here, the first one has to do with questions, and I still do have a lot of questions. So think about what questions you might have right now about fake snow or just snow in general. For me, I want to know what the traits are of snow. Okay, what does it look like, the physical traits? Well, I know that's white. Okay, there's a trait. I know that it's cold, so that maybe answers some of those questions. But other than that, that's about all I know for now, that it's cold and it's white. Maybe that it's made out of water. So I want to at least take those questions and use it as a foundation for me of how to copy and replicate my fake snow. My next step is to imagine, what could I do to make fake snow? Well, I said it was white, so think of some things you might have in your kitchen that are also white. Okay, I can make a list of those things, try to mimic the ingredients that might be part of fake snow. And there are a lot of things here, so I think might want to narrow it down. And I think you know where we're going with this, because we left some of those materials on our list when we invited you to our afternoon here. So now it's time to go ahead and plan. What are the ingredients I'm going to be using for my recipe? And again, I'm using just a recipe for myself because I'm the chemist. And if I do this on a small scale and it works, I can hand it off to the engineer, specifically a chemical engineer, and that person is going to enlarge it on a much bigger scale because that's what their job is. So here's my plan. And just so you know, boys and girls, plan to get your hands messy, okay? This one's going to require your hands to get involved and get messy with your ingredients. So while I get my materials ready here, check and see what are some things that you may need from our must-have list. Okay, there's some things like bowls. At least 2 bowls would be good. You're going to definitely need something called baking soda. So it looks like that. It's a kind of an orangish box I'm sure you've seen in your kitchen. You're going to need a cup. You're also going to need some water, a spoon, some liquid soap, and definitely paper towels, because this is going to be pretty messy. Okay, so I'm going to go ahead and get this ready. Also, if you have some may-dos, or may-haves, I should say, then you can gather those as well. So when we're done, if you want to decorate your snow creature or your snowman or snowwoman, you can do that as well. Okay, so I'm almost ready with my materials here. Again, if you don't have these all right away, boys and girls, go ahead and you can even pause our video right now and come back in however long time it takes you to do that. Okay, so don't feel like you have to rush. You can pause this video and then you can come back to it a little bit later. Okay. All right, so I think I'm almost ready with this. Let's go ahead and take a look at how our elements are going to work. So let's see if we can straighten this up just a tad. And maybe focus that in a little bit more. Okay. All right. So as I mentioned those ingredients, I have them all laid out here on my table. Again, I'm working in a space that's going to get pretty messy. I happen to be in my kitchen, so I know this is going to be okay. Don't do this in your living room, boys and girls, if you think your parent's going to be a little bit upset. So put all your materials someplace where you don't mind it maybe dropping on the floor a bit. Okay. All right. So the first thing I'm going to do is I have a cup. And your cups might be a different shape and size. So whatever cup you're using, you're going to have to kind of gauge how high or how much you want to use in your cup. But this is my form of measurement, is going to be this particular cup. We know that the cup is going to be my measuring spoon. So I'm going to go ahead and scoop out a little bit here. And as I'm doing this, I'm going to be taking notes of how much I'm actually using of my baking soda. So here's my baking soda. It's about a little bit more than halfway full. I'm going to drop that in there and then move that off to the side. Okay, the next thing I'm going to do is I'm going to start dropping in little spoonfuls of water. Okay, little spoonfuls of water. So I'm taking my spoon. I'm going to start with 1 scoop and kind of mix that all in there. All right, make some observations. Remember, you guys are scientists still right now. And I'm thinking, okay, that's way too clumpy. I don't think I can really do anything with that yet. So I'm going to add now a 2nd scoop. Okay, pour that in there. Okay, it's really bright white, but I think you guys can maybe tell from if you're practicing right now with your experiment. Okay, it's still pretty clumpy. I don't know if it's really going to hold together, so I'm going to do maybe 1 more scoop or spoonful. It's okay if some baking soda gets into my water. All right, now it's starting to work. Okay, make some observations again, just like we did with the solids liquids demonstration. What are some things you're noticing about your snow? Is it the right consistency? Does it remind you of something else that maybe is similar to it? Okay, I'm going to get my hands all messy in this. I'll put my water down here so I don't knock that over. All right, actually, so as I'm doing this, I'm starting to make some mental notes that I'm going to write down a little bit later here. Okay, and I'm noticing it feels a lot like the sand at the beach. Okay. It's got some moisture to it. It's just enough to hold itself together. I maybe need a little bit more baking soda in that, but it's actually pretty good. So I'm seeing that it's still white. it feels kind of like sand at the beach. It's holding itself together. And if I were to smell this, I don't smell anything. That's one thing I forgot to mention, boys and girls, is I've been using words like smell and feel and look, using my senses, but I didn't say taste. Okay, that's really important, boys and girls. We're not here to taste our experiment. If we were doing something engineering with food, perhaps. But so boys and girls, don't go and eat your snow. Okay, we don't want to be doing that. All right, so actually this feels okay. I'm going to stop at this one. So this one's baking soda and water. Okay, and actually what I want you to be thinking about as I do this is think of all the different elements we're using. So this one was baking soda and water. I'm going to hop over now to my other column. You notice there it says baking soda, water, and liquid soap. And I want us to make some comparisons and think, okay, could it be a little bit different? So now I'm going to do the same thing. Did you guys remember how much I needed of each? If you remember, I had about almost a full cup of baking soda. And I remember I needed 3 spoonfuls of water. So I'm going to do 2, 3. So right now it's a ratio of 1 to 3. Now the only thing I'm going to add different in this one is I'm going to add a little drop of liquid soap. It can be dish soap, it can be maybe your bathroom soap, and I'm just going to put a little drop in it. So here's my liquid soap. It's in another container, and I'm just going to put a tiny drop in that. And just squish it all in there. Okay, so I'm already starting to feel a difference. Okay, so what are you adding to yours right now that maybe makes a difference? It still feels like the first batch. That's an observation. It still feels a little bit moist. I can clump it. But now I definitely can smell something to it. It smells like soap. It smells kind of floral. All right. So actually, I think this one might work out pretty well. I think too, I maybe didn't put as much water with my spoon, because I think some of my spoon didn't get it. So I'm going to go ahead and put this here on this plate, and I think I can start to make a snowman out of this one. I really like how this consistency is working. Okay. All right, are you guys writing down? If your hands aren't too messy, write down some observations of what your snow feels like and what it looks like, and add those to the chat, because we're going to actually take those notes. And I'm going to zoom in here a little bit. Take some notes of it, and we need to all describe and record our findings. Okay, that's what scientists do. They record their findings. So if someone were to replicate this, they would know exactly what to do. All right, I think the head part's a little clumpy. All right, not too bad. What do you think? Okay. All right, so as I wipe down my hands here, you're going to need to get those paper towels as well, boys and girls. I said it was going to be messy, right? Okay, I'm going to hop back over to my whiteboard, and I want us to go ahead and start recording our findings. So for what it looks like, I definitely know it looked white. Both types were both white. This one on the left, the first one, the baking soda and water, felt pretty clumpy. I'm going to use that word clumpy. And I'm going to compare it to beach sand. Like, here's my eye, like beach sand. And then my baking soda, water, and liquid soap, that one was also clumpy. But actually it felt a little bit softer. I think because the soap kind of softened it up. So it was softer than the other one. Under smell, this one didn't have any smell. No smell. But my liquid soap definitely smelled, we call the word floral because it smells like flowers. Maybe you have soap that smells like lemon. Mr. Bruder, do we have anyone who can share with us how their snow came out?
Yes, Mrs. Hughes, I was waiting for you to call us in because there are some great ones from these scientists and engineers out here.
Oh, awesome.
Going back a little bit to the beginning when you talked about baking soda, Avery was wondering, would baking soda be considered a solid?
Well, I think so. Even though it's pretty powdery, it's definitely not like a liquid. You're right. So baking soda is considered a solid. It's just in a very clumpy, crumbly form. Sand, for that matter, is a solid. Okay, so yes, baking soda is definitely a solid. It's just a lot looser than maybe the solids that you might be thinking of, like a pencil or a computer.
And then we had Sophia and Cody kind of asking some similar things about making a comparison between fake snow and real snow. If we were to feel both of them, would they both feel the same? What differences, what similarities would there be?
That's great. And you know, to be honest, I mean, I think with this fake snow, it feels pretty close to what I think real snow might be. Again, I haven't really been to the snow in a long time, but when I was there, I definitely know it's cold. I can tell you right now that this snow I'm feeling doesn't feel that cold to me other than the water. So that might be one thing we would have to think in our next step with the improve is how can I improve my snow to make it even cold like real snow?
Awesome. Thanks, Mrs. Hughes. Yeah, we're getting a whole bunch of messages in about what their final result is feeling like. So hopefully we can share a few of those later.
All right, that's fantastic. Okay, so let's go ahead and talking about our improve stage. We're going to hop back to that and talk about if we were to improve this just a little bit more, what might that look like? So what would you do to improve your design, the quality of your design? Would we try using even other liquids besides the dish soap that I had? There's all kinds of white things in your house, but of course we want to be safe with what we're finding, but you can certainly experiment on a small scale with adult supervision. We had a list of may-haves like the toothpicks or buttons or even aluminum foil. So if you look on that picture on the right there, I went and found some things in my kitchen. I kind of decorated my snowman up with some toothpicks and a little foil hat. So think of what you could do to improve your own design. And the improve stage is really important because that's where the engineers really fine-tune what they're planning to do. Okay, boys and girls, so I think what we're gonna do is if you are finished with your snowman or snow woman or snow dog for now, wipe off those hands, okay? Because we're gonna wrap up with our design process and then we have that Kahoot coming along. So let's go back to our EDP. We wanted to make fake snow. We know we didn't have it here. We came up with different ways and imagined what's in our household that might work. We planned some ideas of a few elements and we tested them by creating combinations and different ratios. Okay, and by the way, I'm actually going to go back a bit here. Talking about ratios, we were mentioning the chemical engineer. Chemical engineer is again on the bigger scale. So I want you to take a look one more time and how we're going to improve it. Because if I were a chemical engineer, I'm going to think, well, how would I want to make this bigger for my family, right? So if I remembered in my recordings, I used baking soda. This would be just for my serving, my batch. I used just 1 cup. Okay, I'll make a little icon for my 1 cup. Okay, this one's gonna be just for me. And then for my water, I used 3 spoonfuls of water. So for my family, how can I improve this? How can I make this bit better? How can I make this bigger as a chemical engineer? Well, I have 3 members in my family, so I would need to take these measurements and do a little math, right? So for all 3 of us, right? 1 cup of baking soda, 3 cups of water. 1 cup here, 3 cups, 1 cup and 3 cups. So total, I'm sure you guys can do the math really quickly. I would need at least 3 full cups of baking soda and 3, 6, 9 spoonfuls of water if I were to make this batch even bigger. Okay, and that's what the job of a chemical engineer is going to do. So you can see how important this all is to record our data as chemists. Okay, so I would challenge you to also count up how much do you need for your family. What kind of things would you need to make your family's batch even bigger? Okay, all right, so now we can go back to our design process, and we talked about the improving. So I hope you guys enjoyed making this. All right, hands clean, hopefully. All right, we're gonna start a Kahoot game. So in a separate window, not a tab, you're gonna want to have those separate because you wanna see my screen and then your Kahoot screen for your answers. The pin is right there. You can join us at kahoot.it or with the app. And there's our pin. So I'm gonna go ahead and hop over to my Kahoot game. And I will see how we can join us there. As I'm hopping over to the game, Mr. Bruder, do we have any last questions or wonderings about our experiment?
Yes, we have some great observations about what their fake snow ended up feeling like, smelling like, and all those observations. So if it's okay, I'd love to share a bunch of them with you right now.
Absolutely, we have some time.
Perfect. That'll give our friends time to get into the Kahoot game as well. We had Sophia, who was sharing that hers kind of feels like hard, wet sand. Almost like the kinetic sand you can get at the store. We also had Christian, who was sharing that his feels like a foam or slime.
Oh. Yeah, I know a lot of us have made slime from scratch before too.
Yeah, definitely. I know that's popular. And then Lorenzo was sharing that his feels sticky and gooey.
I like that adjective, Lorenzo, sticky and gooey. Yeah, I forgot gooey is a good one to say.
Zach was saying how his is so cool and soft that it's kind of weird the way it feels. Another one that we had out there, and this was more of a question, is what can we do if our snow is kind of liquidy and we want to make it harder?
All right, I'm glad someone asked that question because when I was playing around with this, I started to think, well, maybe that first batch was too gooey. I think what I would want to do is measure out just a little bit more baking soda and add that into the mix. But what's really good, boys and girls, is that if you use measurements like just a spoon, and that's your standard of measurement, you can start to calculate and count out how many you need instead of just guessing, right? And think of how chemistry works. We've mentioned how it works for medicine, how it works for environmental sciences, and how we have chemists out there who are trying to develop really important, cool ways to make our environment cleaner. But you guys are using chemistry every day. There's chemistry in your kitchen, of course. So if your family loves to bake, I love to bake, you have to use measurements. So when we're asking like how much more do I need to put in or how do I make the snow a little bit harder, you really have to do some tinkering and playing around with it, because if you do too much or too little, you're going to be going back and forth all day. And with baking, they have a recipe. So I got to stick to my recipe, otherwise I just wasted a bunch of ingredients, right? So measurements are important. That's why when we learn our math, boys and girls, it's not just, you know, there because your teacher told you. There's actually some great applications of why we use math and measurements in the first place.
Awesome. Thanks for sharing that with us. And one of my favorite questions, I love all the questions, but one of my favorites is about the careers that you mentioned. Christian was asking about what are some of the things that you mentioned. Chemists are a type of scientist. So what are some of the things that chemists do in their field? Okay, well, it's such a big word and so many smaller chemistry disciplines. It's a fancy word, like different sections. So for example, I'm going to use the analogy of like myself. I'm a teacher and you have a teacher. Well, there's tons of teachers, but someone might ask them, well, what grade do you teach? And that's a specific type of teacher. Okay, maybe they teach for elementary school, maybe they teach for high school or even a college. Okay, so the name, a chemist, is one group, but there's tons of other branches that come off of there. So just off the top of my head, we have an environmental chemist. And those people, again, usually are trying to create ways to help the environment. So I mentioned about
Biofuels, that's a huge career right now, because if you drive around town, you probably see a lot of people driving electric cars or hybrid cars. And those hybrid cars, chemists help create the machinery parts inside, the chemicals to make it work. Okay, some fuels right now, well, the fuel we typically use for gasoline is a mixture of petroleum, which is normal gas, and corn. Well, someone didn't just come up with that, you know, off the top of their head. They actually had to do some chemistry and figure out what's the right mixture to keep it safe. If you have solar panels on your home, chemists were helping to design the panels themselves, because there's lots of chemistry along the flats of those panels and inside if you were to try to dissect it. So there's so many applications for chemists right now in the world. It's more than just playing with liquids. So don't think a chemist just deals with liquids. They deal with all sorts of different things, solids, liquids, and gases for that matter. Wow, I see a lot of people are joining. We got almost 350 people so far. It's amazing.
Yeah, and there's still more coming in. While we wait a little bit longer to get some more friends in, can we share one more question with you, Mrs.
Absolutely.
Hughes? You talked about chemists. I know you also talked about chemical engineers. Can you tell us a little bit about what they do too?
Of course. So as I mentioned in the beginning, the chemist is going to be the person or persons who are testing things out. Remember, that's going to be what they do, is they're testing as a scientist. Let me try this a little bit here, and if it works, great. If it works out well, then they pass that information on to chemical engineers, who are going to design ways to make it happen on a bigger scale. So for example, we made some fake snow. What if I want to make the fake snow for my entire room? Well, it might be hard for me just to go and get a whole bunch of baking soda and spill it all over my room, right? So a chemical engineer is going to have to find a way to design and make those chemicals work for them without maybe wasting a lot of other materials, and keeping the recipe so it still focuses and works. Okay, so chemical engineers are really important because they help us have all this wonderful technology and these inventions, but just on a much bigger scale.
Awesome. Thank you for sharing that with us. You know, I'll be honest with you, Mrs. Hughes, there's so many great comments and questions coming in. I could keep going with you, but I also know we have a whole bunch of people ready to play Kahoot.
Yep, I do see a lot of them there. Okay, so I think we're going to go ahead and get started as those numbers keep on going. Looks like we're already approaching almost 260, 70 maybe, but I'm going to go ahead and get started, but feel free to jump in and you might be one of those lucky winners. Okay, snowy science of chemical energy. 3, 2, 1, here it comes. First question. Kind of gave it away just earlier with all those questions, but what is the main role of a scientist? Wow, those answers are coming in fast. Some people know it. Our choices are to create and build models. That would be red triangle. Is it to read science books? Blue diamond. Is it to test and observe experiments? Yellow circle. Or is the main role of a scientist to play in the snow? Green square. What is the main role of a scientist? And if you were listening carefully, we kind of gave you this answer in these last couple of questions, Mr. Gruder and I were seeing the difference between a chemist, which is a type of a scientist, and a chemical engineer. So what's their job? Is it to create and build models? Is it to read science books, test and observe experiments, or to play in the snow? And our answer is, of course, to test and observe experiments. They're the primary starting point when it comes to understanding this. And looks like we had a good chunk of us who got it right. Let's see who's going to be in the lead. Rockstar Lark. Okay. Let's try the next one. We got so many people. We have interesting names out there. Okay, number 2. The big difference between a chemist and a chemical engineer is a chemist tests chemicals on a small scale, red triangle. A chemical engineer creates results on a large scale, blue diamond. A chemist may develop better medicines or car fuels. Is it yellow circle? Or is it all of the above? green square. The difference between a chemist and a chemical engineer. Again, red triangle, they test chemicals on a small scale. Blue diamond, a chemical engineer creates results on a large scale. Yellow circle, a chemist develops medicines or car fuels. Or is it all of the above? Nice, okay. So this looks as interesting. Kind of everyone wanted to go towards one or the other, but actually all three of those are correct. So it is all of the above, very good. And Swift Yeti has now taken over the lead. Okay, question number 3. Which is not a mixture? Which is not a mixture? His one is not questions. Is it lemonade? Red triangle? Is it fruit salad? Blue diamond? Is it trail mix? Yellow circle? Or is it a peanut butter and jelly sandwich? Green square. Which one is not going to be a mixture? And if you notice, you have a little picture there that might help us remember the difference between mixtures and solutions, right? So think back to what we had, the mixture. Which one was that in our glasses, of our 2 glasses? Which one is not a mixture? Is it lemonade, fruit salad, trail mix, or a peanut butter and jelly sandwich? Which one is not going to be a mixture at all? You got over 200 answers coming in. Okay, lemonade. Ooh, a lot of people thought peanut butter and jelly sandwich. Yeah, you kind of, I'm thinking of those jars of peanut butter where the peanut butter and jelly are mixed together. Yeah, like the one at the store is already made for you, but lemonade was the correct answer. You can't get the lemonade back out once you mix it. Think of like when you mix your own at home. All right, so sturdy, I can't pronounce that. Echna, I know that animal, but I can never pronounce it correctly. But wow, 2,436 points so far. All right, what happens to matter? And we learned our forms of matter, solid, liquids, and gases. What happens to matter in a solution? Does it melt? Red triangle. Does matter float away? Blue diamond. Does it dissolve? Yellow circle. Or does it become solid? Green square. What happens to matter in a solution? Okay, and then our little picture there, that's going to be our helper. Okay, they use actually some more scientific terms in that picture there. If you really want to get into it, that thing we put in, think of the glass number 2. What was in glass number 2? I believe it was the salt. That's called a solute, and then the solvent would have been the water. So that kind of should give you away the answer. What happened to that salt? What happened to the salt? Okay, very good. It dissolves. All right, so 105 got that one right. Let's see who's in the lead again. Epic Piranha. All right, guys, you're doing so well. I think some people are going to really like this next question. Last question. We couldn't leave to this afternoon without throwing this out, could we? Who was Anna's chili buddy? Let's see how many fans we have out there. Was it Elsa? Red triangle. Was it Sven? Blue diamond. Was it Kristoff? Orange circle. Or was it Olaf? Green square. And hopefully I'm not hearing some kids just drone. Oh. You knew it was coming, right, kids? You knew it was coming. We couldn't leave today without mentioning something to do with the snow. All right, maybe we can cue some music. Who's gonna sing? All right, who was Anna's chili buddy? Elsa? Sven? Kristoff? This could put someone in the lead just by getting this answer right. Or was it Olaf? And over 200 answers coming in with 3 seconds left. All right, yay, we have some Disney fans. We know it was Olaf, our buddy. Okay, let's see who was on our podium today. In third place, Knowing Badger, okay, out of nowhere. Number 2, Lucky Gator. Okay, we got some alligators. And number 1, who's it going to be? Epic Piranha. All right. Epic Piranha got over there with the runners up. Okay, thank you, boys and girls. That was awesome. Let's go ahead and wrap up our fun game and our afternoon together. So if you enjoyed what we did today, all of our fun maker activities, we have our Innovation Instruction YouTube channel with several playlists for you to guys come on back and watch any of them at any time. We have all of the videos we've been doing throughout our school year so far from every Friday from our other teachers. So please take a look at that if you can. And there's many more STEAM activities you can enjoy from there. Okay, along the same lines of snow and water, or at least water, I want to invite you to come on back next Friday. We have our wonderful innovation teacher, Miss Chrissy Bystrike, who is from the Hydro Station, who is going to be building a water pipeline. That's going to be next Friday, December 13th at 1 p.m. right here in Teams again. And again, be sure to ask your teachers, remind them, they'll have all the details. And adults, if you're watching, feel free to check our updates on Twitter. We usually have everything up there posted for the week that's coming up. All right, boys and girls, thank you so much for joining me. I really enjoyed making some fake snow with you. You guys stay safe and we'll see you next time.
Mrs. Hughes, can I share one last thing with our viewers?
Absolutely.
Other than building a snowman? If you could go back to your last slide, our event for Mrs. Bystrike will actually be Friday, December 11th at 1 p.m. So Friday, December 11th.
All right, so that's December 11th, boys and girls. We know they're every Friday, so please check with your teachers. We'll make a note instead. December 11th will be our Hydro Station event. All right, everyone, take care, enjoy your snowman, and we'll see you next time. Bye.